Sequoia National Park is home to extensive tracts of mixed conifer forests made up of towering old-growth cedars, firs, and pines. In certain areas where conditions of temperature, moisture, and sunlight are just right, giant sequoia trees dominate the scene. One feature of this ecosystem is frequently recurring wildland fire, an important factor in the giant sequoia's success.
Turn back, yep.
A natural wildland fire would have been caused by lightning. We think of those when they occurred in the past, they were probably mostly surface burns. They did kind of create some scarring in some of the sequoias, and that's how we can document when those fires occurred, by fire scars. They created gaps periodically when there was a sequoia that died. An area would burn hot. That would create bare mineral soil, and that would be generally the areas where we'd see giant sequoia regeneration. Those could probably occur anytime, probably from May through the fall, whenever we got lightning and it was dry enough. When you think of fires in the past, there was nobody really suppressing those fires, so any fire that got started could burn all summer long. Looking at the tree ring records of fire scars, we would estimate anywhere between 10 and 25 years, kind of an average of 15 or so years between fires. The seeds are so small from a sequoia, they really can't get germinate and establish if there's much litter and duff on the ground. So they need that bare mineral soil, and there's probably a nutrient flux with that and reduced competition from other species. And then they also like those gaps that are created by fire. That's where the trees tend to grow the fastest. They're not suppressed when they're under an understory. Sequoias also have what I consider a semi-serotinous cone. You know, they are a very long-lived species, so big trees can hang on for decades and decades or hundreds of years. They started doing some research in the middle of the 60s. Part of that research was doing a few burns. And following those burns, they noticed that there was a lot of small sequoia trees germinating in those areas.
As the story was told to me, was that they lit the area and they thought they burned it way too hot. But it was following that year in the early 1960s, they came back and they saw a carpet of baby sequoias. And they realized that that part of that heat is needed not only to burn the dead and down fuels, but also to clean the soil of those materials so the tiny sequoia seeds can reach the dirt.
And the first real operational prescribed burn was 1969 at Redwood Mountain. And there was a series of those burns. Still somewhat, we were still kind of learning the ropes up through the 70s of Redwood Mountain. And then at the end of the 70s, we started moving into other groves.
There's a common misnomer that sometimes we let fires just burn, but we are in fact managing fires every time. When we look at how fire interacts on the landscapes, we look at the long-term fire effects and the long-term fire ecology of that area. Is that we know fire is needed for the health and welfare of the ecology of those groves. We know this from dendrochronology and looking at those fire scars. We know it from fuel loading and how changes have happened in these groves with further propagations of, say, fir trees versus sequoias because of fire exclusion.
Part of restoring our resources for future generations depends on our ability to put fire back into a fire-dependent ecosystem.
Fire may be really important in creating sequoia groves that are more resilient to these changes, particularly climate change.
Sequoia and Kings Canyon National Parks are over 125 years old. The National Park Service is just over 100 years old. However, these forests, these special places, have been around for thousands of years. Taking a proactive approach to fire on the landscape not only makes the parks more enjoyable now, but also makes them more enjoyable for future generations.